Hello my geniuses, welcome to another pharmacological lecture series. Today it's your great science tutor Lorenzo, and today we'll be talking about cholinergic transmission, because in my last video I talked about the autonomic nervous system, which is divided into sympathetic and parasympathetic. So we'll be starting with the cholinergic transmission and later talk about the cholinergic agonist. So we want to talk about the cholinergic drugs, then later talk about the androgenic drugs, then we'll finish up the drugs for the autonomic nervous system. So now stay throughout the course of this video, always watch my video, and if you are just joining me, make sure to subscribe and turn on your post notification button so that anytime I drop any video, you'll be sure to be notified. Make sure you watch the autonomic nervous system video before you come to the cholinergic transmission. Then when you do this, it will be quite easier for you to understand. And if you want me to make any video for you, make sure to drop it down in the comment section so that when I go to it, I'll make that video for you. So let us jump right into the video. In our last video, we discussed about the schematics of the autonomic nervous system, which has been divided into sympathetic and parasympathetic, and how they control autonomic action, involuntary action that involves the heart rate, blood pressure, movement of food, and a lot of stuff. So we have discussed it, and we said that the sympathetic nervous system only controls variously. The sympathetic nervous system only controls majorly the blood pressure and the heart rate, while the rest is controlled more and activated by the parasympathetic nervous system. So in this one now, we'll be talking about the drugs that controls the autonomic nervous system. So we have discussed about the schematics and the introduction to the autonomic nervous system in my previous video. So in this one, we'll be discussing about the drugs that now attack or controls the autonomic nervous system. And these drugs are they are based on their neurons and their mode of actions and a lot of stuff, and also the neurotransmitter they are secreting. So now we have what we call the cholinergic drugs, and we have the androgenergic drugs. Keep it, write it down now. We have the cholinergic drugs and we have the androgenergic drugs. Now the cholinergic drugs secrete what we call acetylcholine, which bind to a receptor, while the androgenergic drugs secrete what? Epinephrine, or we call it noradrenaline, and we have adrenaline, or we call it epinephrine. Now these two is what we will be talking about, because they will bind to the receptor and provide an action which involves contraction or eliciting any physiological response. So that's what I want to talk about now. So in this video, we'll be focusing more about the cholinergic drugs, and under the cholinergic drugs, we'll start with the cholinergic transmission. So what is the cholinergic transmission? It's just a communication between the presynaptic membrane, which is the cholinergic neuron, and the postsynaptic membrane, which is the muscle that is being innervated. So the communication between the presynaptic membrane, which is the cholinergic neuron that secretes acetylcholine, and the postsynaptic membrane that produces the receptor where acetylcholine binds to elicit its physiological response. So the communication between these two is called cholinergic transmission. And one thing you have to know is that the cholinergic neuron has the preganglionic fibers, and their preganglionic fibers innervate and terminate the antennal medulla. Don't forget, their preganglionic fibers innervate and terminate in the antennal medulla. They have an autonomic ganglia. And this autonomic ganglia innervates both for sympathetic and parasympathetic. But the preganglionic fibers innervate and terminate in the antennal medulla, while the autonomic ganglia is present in both parasympathetic and sympathetic fibers, and the postganglionic fibers of the parasympathetic nervous system specifically secrete acetylcholine. Don't forget, the goal of all these things is that they secrete acetylcholine directly. And when they secrete acetylcholine, what happens? Acetylcholine binds to the receptor on the postganglionic fibers or the postsynaptic membrane to elicit this physiological response, which is contractions. So it can contract both skeletal muscle and also both smooth muscle. Also, you can see cholinergic neuron innervating muscles of somatic nervous system. What is the somatic nervous system? The somatic nervous system plays roles in voluntary control of muscles. So specifically, So when they play a role in voluntary control of muscle, so with somatic nervous system, you can control your muscle very well. And which neurotransmitter works on this? Is this what? Acetylcholine. So somatic nervous system releases acetylcholine, and when they release acetylcholine, it binds to the receptor on the postsynaptic membrane in order to what? Elicit contraction. Don't forget. Also, you can also see what cholinergic neurons in the brain, especially in the central nervous system. In the central nervous system, you see cholinergic neuron there, and when they secrete acetylcholine for the purpose of what? Memory retention, cognitive ability, and to carry out your daily activity. For you to form conversation, for you to store information, the acetylcholine is released by the cholinergic neurons in order to effect this what? Activity. And specifically in the temporal cortex, in the retinal area, in the hippocampus, you can see acetylcholine neurons there, which is what? Cholinergic neurons present. And now, absence of these neurons or a decrease of these cholinergic neurons causes what we call Alzheimer's dementia. So dementia, under dementia, you have a type called Alzheimer's. So this is when there is what? Loss of cholinergic neuron. There will be loss of memory and other neurological deficits. And this deficit affect the patient, and when you affect the patient will not be able to carry out his daily what? Activity. That's why some drugs we'll be discussing here, especially the what? Acetylcholinesterase inhibitors, can all help you to do what? Reduce the what? Acetylcholinesterase enzyme present in the synaptic cleft, and when they reduce it, they increase acetylcholine on the receptor to affect the response. Don't forget. The next is the stages of what? Cholinergic transmission. So for cholinergic transmission to occur, first of all, you have to know how to release and how to synthesize what? Acetylcholine. So what are the stages of cholinergic transmission? So the stages involves one, you have to synthesize acetylcholine. So first one, synthesis of acetylcholine. Then when you synthesize acetylcholine, you now have to store acetylcholine. When you store acetylcholine, after storage, when time comes, you release acetylcholine. After releasing acetylcholine, what will acetylcholine do? It will bind to the receptor, so bind it. So we have synthesis, we have storage, we have release, we have binding of acetylcholine. Then after you bind to the receptor, some acetylcholine will be degraded by an enzyme, which we'll be talking about. So after they are degraded, so some of them will be recycled. So we have synthesis, we have storage, we have release, we have binding, now we have degradation, and we have recycling. So these are the 6 most important steps on what? Cholinergic what? Transmission. So we'll start with synthesis of acetylcholine. So how can acetylcholine be synthesized? First of all, acetylcholine contains 2 main substrates, which is what? Choline and what? Acetyl-CoA. Choline and acetyl-CoA. Now, acetyl-CoA is present in the mitochondria of the what? Of the cholinergic neuron. So there's a mitochondria, they are present in the cytoplasm of the cholinergic neuron. So that's where you secrete your what? Acetyl-CoA from. Now, choline is not present in the cytoplasm, so choline enters into the cytoplasm using a sodium cotransport. So choline cannot just enter like that, so it needs a carrier, which is what? Sodium. So sodium facilitates it inside by the help of an ATPase. So sodium choline ATPase allows the transmission and the what? Entrance of choline inside the cytoplasm. So when choline is transported by sodium inside the cytoplasm of the cholinergic neuron, what happens? It then binds to what? Acetyl-CoA. But this can be inhibited. It can be inhibited. So this transport of sodium can be inhibited by what? Hemicolium. So hemicolium enzymes or hemicolium drugs can what? Prevent the uptake of choline into the cytoplasm. Don't forget, hemicolium. So now when sodium facilitates choline entrance into the cytoplasm, what happens? So choline will be combined with what? Acetyl-CoA. Remember, acetyl-CoA was gotten from the mitochondria, and acetyl-CoA is always gotten for what? Glycolysis. So when the end product, the pyruvate, enters into the mitochondria, what happens? It uses what we call pyruvate dehydrogenase complex to form what? Acetyl-CoA. And when you form acetyl-CoA, acetyl-CoA then enters into the cytoplasm, then binds to what we call choline. So when it binds to choline, what happens? It will form what? Acetylcholine. So what enzyme is used? The enzyme here is acetylcholine transferase. Acetylcholine transfer. So this transfer is transfers acetyl-CoA to what? Choline. So if acetyl-CoA is transferred to choline, it forms what? Acetylcholine by a transferase what? Enzyme. So now, remember, hemicolium prevents the what? Transport of choline into the cytoplasm. Hemicolium, don't forget. So now we have formed acetylcholine. So what happens? We move to the next step, which is what? The storage of acetylcholine. So how can acetylcholine be stored? So acetylcholine now is transferred into the what? The synaptic vesicle. Now, synaptic vesicle has small storage units present in the what? In the nerve terminal, which is the cholinergic nerve terminal. So they are present there in order to store the neurotransmitter for a while until they are what? Released. So now all the acetylcholine formed will be transported into the synaptic what? Vesicle. So for storage. So now they are transferred or they are transported into the synaptic vesicle by a VAT enzyme or by a VAT, which is a protein transporter. Don't forget. First of all, we transported choline inside by a sodium choline transporter. Next thing we now do is to transfer acetyl-CoA to choline to form what? Acetylcholine. And after that, we now have to transport what? Acetylcholine and to be stored into the synaptic what? Vesicle. So they can be transferred by a transporter called VAT. We call it what? Vesicular what? Activated transporter. This vesicular activated transporter transport what? Acetylcholine into the synaptic vesicle for storage. Don't forget. The first one, sodium transport choline into the cytoplasm of the cholinergic neuron. Then next, after acetylcholine is formed, acetylcholine is transported by a VAT transporter inside the synaptic vesicle. So now again, VAT can be inhibited by what we call vesamicol. So vesamicol drugs, where when you give patient vesamicol or when you give patient something containing vesamicol, it prevents the what? Storage of acetylcholine in the synaptic vesicle. So don't forget, hemicolium prevents the transporting of choline into the cytoplasm, while vesamicol prevents the storage of what? Acetylcholine. Don't forget. So vesamicol inhibits VAT. So now acetylcholine is stored in the synaptic vesicle, waiting until it is released. So what next? When it is stored, now when there's a transmission of impulses from the cell body to the nerve terminal to the axon, there's always a surge of of sodium. This increase or surge of sodium ions enters into the what? Neurons in order to facilitate transport. But when it gets to the nerve ending, what happens? The high amount of sodium, it gets there already, so there's no more place for sodium to enter. What happened? The increase and the surge of sodium entering into the what? Neuron causes the opening of the what? Calcium gated channel. So that surge of sodium in the nerve ending or in the nerve axon terminal does what? Open the gates for calcium. So when calcium is entering, when there's influx of calcium, what happens? Calcium pushes the what? The synaptic vesicle to the presynaptic membrane. So you will see it in your screen. So that surge of sodium, because I told you that sodium is needed to transport the impulses or the signals from the cell body to the axon terminal. So when it gets to the axon terminal, that surge of sodium that is entering into the neuron causes the entrance or the stimulates the opening of the calcium channel. Now this calcium channel, when they open, what happens? Calcium flows into the what? Nerve terminal, or we call it into the synaptic knob. So when you zoom in to the nerve terminal, you'll be seeing the synaptic knob. The synaptic knob contains synaptic vesicle. So when calcium begins to enter the synaptic knob, what does it do? It pushes the synaptic vesicle to the presynaptic membrane, which is the surface of the membrane. So it pushes it there. So when it pushes it there, what does it want them to do? So when it pushes it there, then it now what? Causes the opening of the synaptic vesicle. When it opens, it now releases the acetylcholine to what we call exocytosis. Are you following me? Now we have talked how they are synthesized, we have talked how they are stored, and now we are releasing them. So we release them by exocytosis caused by what? Calcium. Calcium can be released excessively when there's a presence of a black widow spider. So when a patient or somebody is bitten by a black widow spider, it will allow the surge and the entrance of high amount of calcium for continuous flow of acetylcholine Don't forget. Black widow spider toxin is a toxin that when a patient is beaten with it, what happens? There will be entrance of calcium excessively. And this entrance of calcium causes the what? The exocytosis continuously of what? Acetylcholine into the what? Synaptic cleft. But now also botulinum toxins. Botulinum toxins is also a toxin by Clostridium botulinum. The Clostridium botulinum is they are bacteria. So when they what are present in the food, what happens? They inhibit what release of what acetylcholine by exocytosis. So one counter the other. Black widow spider causes enormous release of acetylcholine, while botulinum toxins inhibit what enormous release of what acetylcholine. So don't forget, when acetylcholine is released by the presynaptic membrane by exocytosis, it enters into the synaptic cleft. Don't forget. So we have a presynaptic membrane, we have a synaptic cleft, which is a space in between the pre and post, and we have the postsynaptic membrane. Don't forget. So now the presynaptic membrane releases the acetylcholine into the synaptic cleft. In the synaptic cleft contains an enzyme called, we have two enzymes. We have the what acetylcholinesterase and we have the butyrylcholinesterase. These two enzymes will degrade what acetylcholine, but it depends. In some places, which I will discuss later, we have acetylcholinesterase. In some places we have butyrylcholinesterase. Now when acetylcholine is released, what happens? They are released into the synaptic cleft. The synaptic cleft contains some jelly-like substances that does what guide the acetylcholine to the what receptor. Now the next thing is the postsynaptic membrane. Now the postsynaptic membrane does what? They release receptors. These receptors wait for acetylcholine to be released, and when they are released, what happens? They bind to that receptor. When they bind to the receptor, what happens? They now elicit the physiological response. And there are different receptors which we'll also be talking about later, where the postsynaptic membrane releases it in order for acetylcholine to bind, depending on the location. So now when acetylcholine binds to that receptor, what happens? They open the ion gated channel. When they open the ion gated channel, they allow what ions to flow through for the purpose of what contraction. Now this is release and this is binding to the receptor. Now some acetylcholine that are degraded, I told you, by acetylcholinesterase and butyrylcholinesterase. So when they are degraded, what happens? So they are divided into acetyl-CoA and what choline. Don't forget, they are divided into acetyl-CoA and choline. Now this division of acetyl-CoA and choline causes the what recycling. So these people too, choline now does the same thing by following what sodium. So sodium will facilitate the what the co-transport or the entrance of choline again into the what cytoplasm of the cholinergic neuron. Again, this is what we call recycling. Don't forget. Acetyl-CoA can also be recycled, and also choline can also be recycled, but choline is recycled with the help of what sodium, while acetyl-CoA can also enter for the purpose of what glycolysis, to continue the TCA cycle to produce what energy. Don't forget. So we have discussed the cholinergic what transmission. So I hope this all made sense and you have understood everything we have talked about as the cholinergic transmission, where we started from explaining what cholinergic neuron is. After we explain cholinergic neuron, in the cholinergic neuron we have the pre and post ganglionic fibers and also the autonomic ganglia of the cholinergic neuron. We talked about the cholinergic transmission, which is the synthesis, which is the storage, which is the release, the binding, the degradation and the recycling. We talked about everything and I explained everything to you and what is inhibiting and activating them. So I hope it all made sense to you. So again, if you are new to my channel, make sure to subscribe and turn on your post notification button so that anytime I drop any video, you'll be sure to be notified. So next we'll be moving to the the cholinereceptors or the cholinergic receptor. That's the next video. So the video was broken down into succession, so you follow it so that you understand everything I'm talking about. So after the cholinereceptor, we enter into the cholinergic drugs directly. So you follow the video one after the other. So we'll see you in the next video. Bye bye.